Well, good morning, everybody. What we're going to be looking at today is a structure that is kind of unique, also rather old. I guess you could call this either restoration, preservation, or rehabilitation. It's kind of a little of everything. So, as you can see, this is Town Bridge Road in the town of Canton, Connecticut. It's over the Farmington River, and just recently it received the 2023 Abba G. Lichtenstein Medal at IBC. So let's just begin and we'll go from here. The project description is pretty unique in that it was built in 1895 by the Berlin Bridge Company. Now, back in the latter part of the 19th century, there were many different little small bridge companies that would build bridges. The Berlin Bridge Company was out of East Berlin in Connecticut. It organized in 1868, and then it dissolved shortly after 1900 because it was absorbed by a company that many of us have probably heard of, American Bridge. Now, you can tell it's a 160-foot span, so it's a good-sized truss, single lane, alternating one-way traffic, and quite frankly, the sight lines were less than desirable. Bridge was in poor condition. It was rated the superstructure rating, item 67, was rated a 3. It also was functionally obsolete. So it had a lot of things not going for it. Now, just as an overview, you can see that this is the truss when it was finished, but you went across the Farmington River. The Farmington River is a pristine, world-class trout stream. To be honest with you, having inspected this bridge many years ago when we used to do it with ladders, when I worked with Condot, the fly fishermen were less than happy to see us out there inspecting. There's a large pool below the bridge which is loaded with, I don't know how many fishermen I have in the room right now, but there were many trout in there. You can see them from the deck. So anytime an inspection team's out there disturbing things, you're not welcome. Now, TranSystems was basically chosen by the town of Canton to look at the bridge, evaluate its condition, develop recommendations for the project itself for either rehabilitation or replacement. Now, replacement really was never on the table. We had to inspect the bridge. So we covered everything as far as it went. You had to load rate it. You had to do material testing. Remember, this is 1895. You're dealing with wrought iron pieces. You're dealing with open hearth steel. I mean, never mind any of the new ASTM values. You had to survey the area and the like. You had to go through rehab plans, structure types. Any of the designers I have in the room right now, you know the drill. And then finally, you had to come up with a cost, which is always interesting. Now, what makes, again, the structure unique is that it is a Parker truss. It's one of 2 remaining Parker trusses in Connecticut. So you couldn't very well say, we're just going to dump it and replace it with what some people might refer to as an I-beam eyesore. You have a very unique structure up here. I know I have a tendency to wander. Take the mic. So anyway, looking at this, it's a unique structure. It's a one of a kind, or a two of a kind, if you want to go that route. We had there were goals set for this project to to improve any sort of roadway geometry, the load capacity. This bridge was posted for 7 tons, which made it was severely restricted for traffic. And now you're looking at it, it's historic. Got to preserve that. It's on the National Register of Historic Places. So now your hands are tied on a lot of things, of what you can do. Now, looking at it and what we have, it's historical. Some people might say hysterical, but it's historical. And there was a lot of significance to the fact because it was a unique type of structure where they were starting to do things a little bit differently as you approached the turn of the 20th century. There's some various records that were quite interesting when you did the research in the project and the like. And you just had to always take into consideration that it was on the National Historical Register as well as the Connecticut Historic Bridge Inventory. Now, if you were to go through just come on. I'm not going anywhere with it. Looks like I'm not moving around. But anyway, Connecticut has its own historic bridge inventory of a variety of structures. This bridge is in there along with several others from the late 1800s, early 1900s, variety of structure types. So with that in mind, you can see what we were up against. Now, strange as it may seem, we actually had some plans. Now, this would have been plans that were 128 years old. I don't know how many of you ever dealt with old plans for older structures? You see a lot of the drawings were on linen with ink. Anybody, never mind, forget AutoCAD and the like. You're talking people who would have taken it, if you've ever dealt with linen and ink, and strangely enough, I have very early on in my career. The slightest little mistake and your drawing's ruined. And by all means, you don't let somebody who likes to point and rub at things near your drawing before the ink dries, because it'll become a mess. But you can see on these plans, you've got bridge plans are bridge plans. You know, you've got your elevations, your plan views, and your details. Now, this was a pinned truss. It's a Parker. Now, moving along, we studied it. We came up with four alternatives, but there was one that stood out amongst them all, and it was very much agreed upon by the town and the townspeople. They wanted to keep the bridge. They wanted to keep it in the original configuration. They really did. They wanted it to be up to snuff, but not look like anything had really been done. So you had to do all the work, but somewhat hide it. Now, TranSystems did provide, excuse me, a complete set of rehabilitation plans that included strengthening the bridge. And it was strengthened to carry the old HS-20 load capacity. Now remember I said earlier this bridge was only good for, it was posted for 7 tons. So that's a significant increase in its capacity. Now came the time of what to do and how to do it. Now, what was done on here, let me make sure I didn't skip a slide. No. What we had was, we took the truss off its bearings, and in doing so, it involved mobilizing 2 large cranes. You can see here in one of the photos, looking for the arrow. The arrow's the center.
I have no idea. Good question. Where's the pointer on right.
Which one?
I don't know.
I don't either. It's the first time I've used it.
Yeah, same here. Oh, it's the red one there. There you go.
Yeah, it's the red one. Okay. Sorry for the technical difficulties. Well, what we have is you can see you got a large crawler crane there. And you have, see down below, you have a very large truck crane. Now they were both large, they were both levers. One was an LC 1300 on the crawler that you see there. And the other is as I said, a very large truck crane. I know there's many in the audience today that deal with them on a regular basis and how you move them around throughout your state. This one has a lifting capacity of 600 tons. Weighs 180,000 pounds on 8 axles when it's going down the road. And just to give you an idea on size, I can stand in the wheel wells. Now, as we began, you mobilize the cranes. Now you got to demo the deck. The deck and the floor system was removed. Then the bridge was picked. We picked the entire bridge, took it offline, and then began the project, the hard work. It was totally taken apart. It was shipped off to the steel fab shop where the meat and potatoes of the project were performed. Now, while the bridge was off-site, now these were masonry abutments, again, built 128 years ago. They drilled rock anchors, stabilized everything, new bridge seats, new back walls. They had plenty of time for all that to happen while the bridge was off-site being preserved. Now, in addition to that, you had all your fancy details. Now, I mentioned it was wrought iron. All your ornamental work on the bridge and the railings were originally wrought iron. It did not have the best of railing systems for traffic. Now, if you look in the lower right-hand corner there, you can see the railing is no longer just some MBR or some pickets. You've got some tube rail that's actually crash-worthy and the like. Moving along, as I said, we had to strengthen things. We had fracture-critical members out there that had one bar as the member. You can see again, you look in the upper left, he had additional rods installed to increase the reliability of the structure itself. Now, if this will work. Here we go. The contractor was very nice to provide this for us. You can see the whole piece as it's been shipped back. It's a high speed restoration of the whole unit. And now you see how big the cranes were, where the bridge was off-site. Where they began to pick it. Now, if you can bear with me, this is about 3 to 4 minutes long. You can see you had one pick it, the other one grab it, and then bring it into position. The contractor was Rotha Construction. And they were gracious enough to provide us with this video. Some iron workers going for a ride. You can see the structure itself had been hot dip galvanized, and then a zinc coating system was installed up on top of that. So you really had a duplex coating system for the bridge. So once the bridge, the rest of the truss itself was installed, you then have a new floor system put in, a new corrugated metal deck, and the pavement installed as well. Now, this looks like a very small group for the ribbon cutting. Well, it was December in Connecticut when they had the meeting. And Canton is a small town, so you didn't expect to see a lot of people out. But the ones who really liked the bridge, liked the project, they were there to support it. Now we come down to what we just took place just a couple months ago, actually, where we received the Abaji Liechtenstein Award for the structure, medal for the structure. The two gentlemen in the photo is Mike Cuddy out of our Philadelphia office and Brian McGovern out of our, actually he's my boss, out of the Meriden office. And I'd say thank you. Do you have any questions?
Yes.
Do you have a ballpark of how much, like a percentage of the truss that had to be strengthened in order to get the capacity you wanted?
Couldn't hear him.
Ballpark
I
percentage
could-
of the structure that need to be strengthened. How
Pardon?
much of the bridge had to be strengthened?
Okay. Well, you're dealing with, there were a variety of details that had to be strengthened. Your cords, and as you saw that, the diagonals were also involved there when we added the double rods, where you had a single rod to begin with.
Okay, thank you.
I thought we had another question in the back.
What was the total cost?
I didn't even look at the cost when with the presentation. It was a matter of just putting, I can't tell you that right now, I'm sorry. But I will say one thing, the structure right now, when you figure it was built in 1895, the new one, the new version opened in December of 2021. You're dealing with a structure that has a much longer lifespan to it now, and it's in better shape and stronger than it ever was. But when you look at it, when you look at that photo there, with the coating system on it and the like, we have a structure that's going to last a long, long time. And I guess the key thing for any preservation job is that you want to extend its service life. Well, if it's in better shape today than it was when it was originally built, I think that's been accomplished.
Rich? Is it, I assume did you remove the load posting? You said
Oh,
it was
it's
7
the-
tons.
There's no longer a load, it can carry all legal loads.
It's still one lane.
It's still one lane. There was nothing that could be done about that because you wanted to keep everything else as it was. But it's no longer load posted. It can carry the legal loads. There's no more detours for any sort of emergency equipment or the like.
It's an improvement.
Worked out nicely for it. Any others? Again, thank you.